Now let us take an example of L3 routing in this 4-node topology. So you can see this is a 4-node topology which has 4 virtual machines, or say 4 routers, which have names VM, VM1, VM2 and VM3. Now let us identify the local subnet and the remote subnet for each of these routers. So for the router VM, the remote subnet is subnet 2. So for the router VM, the remote subnet is subnet 2 and the remote subnet is subnet 3, right? And for the router VM1, remote subnet is subnet 3 only. Similarly, for the router VM2, the remote subnet is subnet 1 only. And for router VM3, the remote subnet is subnet 1 and subnet 2. So we have already discussed that how do we find the local subnet and remote subnet. Now, when these routers are fully operational in the network, how does their routing table and the Arp table looks like? So here we have shown you the routing table of all the 4 routers, and against each router there is a small box which shows the Arp table of the router. So let us discuss about the router VM. So the routing table of the router VM will have 2 entries. Why 2 entries? Because the router VM have 2 remote subnets, the subnet 2 and the subnet 3. And remember, we always install the routing table entry to reach the remote subnets. So in the router VM, the routing table entry that we have installed is 192.168.5.0. That is, we are trying to reach the subnet 3. And the next hop IP address is 192.168.4.1, right? And of course, the subnet mask is /24. That is, for this subnet, the subnet mask is 24. And the outgoing local interface is Ethernet 2. So this is the routing table entry which we will going to install in the virtual machine VM in order to reach the subnet 3. Similarly, the router VM also needs to reach subnet 2. For that, we are going to install the routing table entry 192.168.1.0. The next hop IP address is 192.168.4.1 and the outgoing interface is Ethernet 2. That is the same interface. So following the same logic, the routing table entries in the router VM1 and the router VM2 and the router VM3 is shown here. So with the same logic, you can find that the routing table entries of all the routers are being consistent and they ensure that the routers are reachable to remote subnets. So if you want, you can do this as an exercise, create a 4-node topology like this, install these routing table entries in each of your router's routing table or virtual machine routing table and try to ping various IP addresses. Now coming to the Arp table, let us say for the router VM1, the Arp table contains the Arp and MAC address mapping for the neighbors. So VM1 has 2 neighbors, VM and VM2. These are the 2 neighbors of the virtual machine of the router VM1. So what are the IP address of the neighbors? 192.168.4.2. Similarly, the second neighbor of router VM1 is the IP address 192.168.1.2 and it is configured on an interface Ethernet 3 which has the MAC address MD. Therefore, here you have the IP address to MAC address mapping as 192.168.1.2 and the MAC address is empty. So this is the ARP table for router VM1. Likewise, you can also cross-check the ARP table for router VM2, the ARP table for router VM3 and the ARP table for router VM. So here the essence is to show you the fully populated routing table and the ARP table when the routers are in operation. So again, we have already discussed that whenever a router wants to send a packet or whenever any machine in the network wants to send a packet, essentially four fields you should know: the source MAC address, the destination MAC address in the Ethernet header, and the source IP address and the destination IP address in the IP header. So again, in our topology, there is no L2 switch. So MAC table is out of question here. We assume ARP tables of all the routers in the network are already populated because we are focusing on L3 routing alone as of now. Now, what are the operations of network layer in the TCP/IP stack? Now, in the TCP/IP stack, we already know that we have a network layer which is operating above the data link layer, and the network layer performs certain operations. What are those operations? The first operation is the route lookup, which we have already explained. And why route lookup is required? Route lookup is required to decide if the received or locally generated packet is destined to machine in the local subnet or remote subnet based on destination IP address. So router has to decide whether the packet it has received is destined to the router itself or the router has to forward the packet. Then local packet delivery. That is, if the destination IP address in the received packet is equal to the IP address of one of the local interface of the router, it means that the packet is destined to the router itself. That means the router will hand over the packet to the transport layer. That is, the router will consume the packet. This is called local packet delivery. And if the destination IP address in the received packet is not equal to the IP address of one of the local interfaces, that is not equal to the IP address of any local interfaces of the router, and routing entry is present in the routing table for destination IP address, it means that the packet is not destined to the router itself. In fact, the router has to forward the packet to the next hop. Then again, it is possible that the router itself is a source and it can generate the packet on its own. In that particular case, the transport layer, the network layer of the TCP/IP stack has the responsibility to prepare the IP header and populates the various fields of the IP header. Then the fifth operation is the discard the packet. That is, if the destination IP address in the incoming packet doesn't match any route in the routing table entry, that is, there is no matching entry in the routing table, it means the router doesn't know what to do with the received packet, so it silently discards the packet. So going forward, in this diagram we have captured that what actions the router takes when the router receives a packet. So suppose we have a router and the router receives a packet from the previous router. So when the router receives a packet, what is the course of action performed by the router? So the first thing that the router does is that it checks whether the destination MAC address specified in the Ethernet header of the packet is equal to the MAC address of the receiving interface. If the condition is satisfied, then only the packet is delivered to the network layer. Now when the network layer receives the packet, it receives the packet along with the IP header. The Ethernet header gets chopped off right away by the Ethernet layer at the moment when the Ethernet layer hands over the packet to the network layer. So the network layer receives the rest of the packet which has IP header. Now network layer works with the IP header. Using the IP header, the network layer does the route lookup using the destination IP address specified in the IP header of the packet. Now, the result of the route lookup in the routing table by the router could be that whether the router is able to find the matching entry. If the router is not able to find the matching entry, then the router doesn't know what to do with the packet. It simply discards the packet. But in case the result of route lookup is a matching entry, then the router does one more check and it checks whether the matching entry is equal to the local subnet of the router. If no, it means that the packet is destined to some other machine. In this case, the router chooses to forward the packet. However, if the router decides, as a result of route lookup, that the packet that it has received is destined to one of the local subnet of the router, then the router subjects the packet to local packet delivery mechanism. Local packet delivery is responsible to deliver the packet further to the transport layer, which further delivers the packet to the application layer running on the router. We will discuss in detail the local packet delivery when we will be discussing the transport layer. So this is how this entire diagram captures the mechanism and the operations that is performed by the network layer. So once again, the data link layer receives the packet, it hands over the packet to the network layer. The network layer performs the route lookup. As a result of the route lookup, whether matching entry is found or not. If the matching entry is not found, the packet is discarded. If the matching entry is found, then the next thing router does is to check whether the packet is destined to one of its local subnet. Now, if the packet is not destined to one of its local subnet, the router decides to forward the packet. And if the packet is destined to one of its local subnet, then the router decides to hand over the packet to the transport layer. That is, the packet is required to be processed at the local application running by the router, and the packet is not supposed to be forwarded or discarded. It is supposed to be processed locally on the router.